Hi, so I'm going to be answering question 1 from test 3 in physics. So we need to first just draw our mass spectrometer. So we're trying to find out which side is going to be the positive and negative, but in order to do that, then I'm just going to start by writing down what we have and finding the mass in kilograms of our hydrogen and our carbon dioxide. So starting with that, I will first draw a really basic diagram of the spectrometer, and it's going to look like this: a smaller and a larger portion, and then it's going to be going out with a certain velocity which is given to us, and then it's going to hit this one. Anyway, so from there, then I am going to take, there's 2 hydrogens that's given to us because it's H2, so we would times 2 times 1.008, which is the weight of our hydrogen. And this is going to give it to us in grams per mole. When I times 2 times 1.008, that gave me 2.016 grams per mole. Divide that by Avogadro's number, which is 6.022 times 10 to the 23rd. And that gave me 3.35 times 10 to the negative 24. But the thing is we're still in grams, and we need it in kilograms, in SI units. So I would divide by 1,000 grams to get to 1 kilogram of that. And that gave me 3.35 times 10 to the negative 27 kilograms. That's important. We're going to use it for later, and I'll show you my work. So there's me timesing it 2 times the weight of my hydrogen given in the periodic table, dividing by Avogadro's number, giving it to me in grams, and then converting it to kilograms here, giving me 3.35 times 10 to the negative 27 kilograms. Now, I also have carbon dioxide, so I have to do it for carbon dioxide too, finding the atomic weight. So there's 1 carbon times 12.01, the atomic weight, plus 2 oxygens times 16 for the atomic weight. So putting that together, it gives me 44.01. Divide that by Avogadro's number, and that gave me 7.31 times 10 to the negative 23rd. In order to, and then I need to convert that into grams again, kilograms, by dividing 1,000 grams to 1 kilogram. And that gave me 7.31 times 10 to the negative 26 kilograms, and that was for carbon dioxide. Like this. And then there's my answer right there, the 7.31 times 10 to the negative 26. Okay, so from there, we know our velocity. Our velocity was given at 1,500 meters per second. That's nice because we don't have to convert it into anything else. Then we also have E, or our charge, which is Q. And that was 1.6 times 10 to the negative 19, always is, and that's in coulombs. Then we also have our magnetic field, which is 0.75. So using that information, then we can use the equation that the electric field equals force over Q. But we don't know our force yet, so we should first solve for force. Our force equation can be looked at as force equals Q, the charge, times the velocity, times magnetic field, like this. So using this, then we can solve for the force really quick. So we would do F equals our 1.6 times 10 to the negative 19, and then we would times it by our velocity of 1,500 meters per second, and then by our magnetic field of 0.75. Once I plugged that into my calculator, it gave me 1.8 times 10 to the negative 16, and that would be newtons. So that's my force. So using that, then I can use my other equation, my force, or my electric field equals the force over the charge. Let me show you my work. Right there. So there's the answer I just came up with. So now I'm going to use E equals F over Q, which is pretty easy because I have all the information now. So F was our 1.8 times 10 to the negative 16, which we just calculated. And then our Q, or E, was 1.6 times 10 to the negative 19th. So plugged that into my calculator, and that gave me 1,125. And that was newtons per coulomb. And that would have been my E, or my electric field. So there's the first part. Okay, so then it wants to know which side would be positive and which would be negative of our spectrometer. So figured out that the smaller portion would have been the positive, and that the negative portion would have been the larger one because they need to bounce off, and we know it goes from positive to negative. And so this is what they would look like here. The positive portion here and the negative portion here. Okay, and then for the next part, we also know that F equals Q, V, B, or from the last chapter we found out that mass times velocity squared over the radius is also equivalent to that. So I am going to compare QVB equals mv squared over r. I'm going to rearrange it though, and when I've rearranged it, then I would just times the r on both sides, giving me, and then dividing QVB. This gives me r equals mv over qvb, or mv squared. I'm going to just make that simpler by doing 2 mv to get diameter, and don't square it, and then just qb on bottom. That way I just solved and simplified the equation so I can plug in information right there. So now that I have the radius, I can find the distance between them. So I would plug in r equals my 2 times my 3.35 times 10 to the negative 27. That was what I found in the very beginning with finding the mass of one hydrogen, or both of them. And then times it by the velocity of 1500 over our 1.6 times 10 to the negative 19, our q, and then our 0.75. Plug that in, and that gave me 8.38 times 10 to the negative 5th hertz. Oh, sorry, that's not hertz. Sorry, that's just my hydrogen. Okay. So knowing that information, then we can also do that and do it for carbon dioxide. So I would plug in R again, and the only difference is I'm going to plug in the weight that we found for carbon dioxide and not for the hydrogen, which is my 7.31 times 10 to the negative 26 times our 1500 for our meters per second over the same thing we had before, our 1.6 times 10 to the negative 19 over 0.75. Okay, and that gave me 0.0018275 for carbon dioxide. So the very last step that we would need to do is subtract the larger number by the smaller number to find the difference between them. Here's my work for these two. There's the R equation for hydrogen, and the R equation, the radius, for the carbon dioxide. The last step again is to take our largest number, 0.0018275, and subtract 8.38 times 10 to the negative 5th for the hydrogen. Subtracting those gave me 0.0017437. That is the distance between the hydrogen and the carbon dioxide. So that's my final answer for this question right here. I'll give you a second just to be able to see the work I've done here. Anyway, thank you.